How's everybody doing? Welcome back to the channel and a continuation of the testing of the VDE torque wrenches from Laser. Previously I tested these on the Dremotest-E only. I've now manufactured another plate so I can mount up the Wisretec unit and do some comparison tests between the two. These will only be done on the new torque wrench that you see just here because I've actually dismantled the old torque wrench that you see over there to take a look inside, see how it functions, and to see if I can work out what the calibration mechanism is inside the unit. And we'll get into that later on in the video. So back to the actual units themselves. When I did the testing on this, I set the wrench up to the specified torque value, and then I did the 10 tests on this, and then did the corresponding 10 tests straight away on the Wisretec unit, and then set the wrench to the next value, and again tested on this and tested on the Wisretec straight away. That way I'm eliminating any variation I might have put into it by adjusting the actual torque wrench. So we just do a couple of sample tests on this. I'll set the wrench up to the 10 Newton meter setting. You see that's 10.5 there. 10.2 there. I'll flip this around and go straight onto the Wisretec unit. So we've set our torque wrench up to 17.5 Newton meters. Some examples of that one there. We'll go back onto the Ghidorah. Just move the camera over. I'll give this a couple of blasts at 17.5 Newton meters. Okay, that's that one there, and then we'll finally turn the wrench up to 25 Newton meters, which is its max setting. And we'll do a couple more tests, and this time we'll start with the Ghidorah and then move back to the Wisretec unit. So you see there's 20, it's 27. Just reposition the camera again. So that's a sample of the testing that I did on the two units. I'll put the results up, and you can see here there's a couple of plots here. First one is the average percentage deviation between the two units. You can see on the plot there that I've marked the tolerance bands with the two red lines at plus or minus 6%. And down at the 10 Newton meters, the Wisretec actually reads low in comparison to the Ghidorah unit. And the Ghidorah unit is pretty much at the top of the 6% tolerance plus 6% tolerance. Looking at the spec on the unit, I'll just flick the screen over to the specification of the Wisretec. It will read from 6.8 to 135 Newton meters, but the first calibration point I have is actually at 27 Newton meters there. So I've got a feeling that this isn't the best unit to be doing a comparison with. Wisretec do also manufacture a 1/4-inch drive unit that has a 3 Newton meter to 30 Newton meter range. So I've ordered one of those up, but it's going to be a couple of weeks getting here. But when that arrives, I can repeat some of the tests, and hopefully then the testing at the 10 Newton meter value will show a better comparison between the two units. Back to the results plots, and again this comparison of the percentage deviation at 17.5 Newton meter and 25 Newton meter test points. You get a much better correlation between the two sets of results there, with the Wisretec always reading a little bit higher and the Ghidorah reading a little bit lower. At the 17.5 Newton meter range, the Wisretec is just slightly above the 6% tolerance. Ghidorah is a little bit below. At the 25 Newton meter range, they're both well and truly out of spec, close up to 12% deviation there. The other plot on the right hand side is the plot of the averaged values in Newton meters themselves. Not so easy to read that graph, that's why I did the percentage deviation graph, but it does follow a similar sort of trend to the other plot there. Down at the bottom of the table there is the number of out of tolerance readings at each setting. We have 10 Newton meters. The Wisretec have 3 readings out of tolerance, Ghidorah 5. Previously, with the tests on the Ghidorah only, I only had 1 reading that was out of tolerance at 10 Newton meters and 2 for the damaged wrench. 17.5 Newton meters, we have 5 with the Wisretec, 2 with the Ghidorah. That matched the previous test with the Ghidorah and the new wrench. The damaged wrench had 5 readings out at 17.5 Newton meters. And then finally 25 Newton meters, very close. The Wisretec has 9, Ghidorah has 10. Previously that was 8 out of spec and 10 for the damaged wrench. But overall it does average out, and the Wisretec has 17 readings out of spec out of the 30 tests, and the Ghidorah also has 17 with this round of tests. Previously that was 11 for the new torque wrench that I've tested this time round, and then 17 also for the torque wrench that is damaged. But that's the overall results there. I'll clear this all away and we'll take a closer look at the damaged wrench that I've taken to bits. So here we are with the dismantled wrench. This is as far as I've been managed to dismantle it. The only section I can't get to bits really is this section with the main body, with the aluminium tube here that appears to be joined onto the head section inside. You can see this is actually embedded into the plastic moulding. There's the crack there of the damaged insulation, and I can't actually see any line or anything from this tube joining onto the head, so I presume it's been welded together and then dressed down in some sort of manner. There is a slight join line evident across this, so it's like this is made in 2 halves, so you make up the tube section and the head and then glue this insulated section around it. So that's as far as I can get that to bits without causing more physical damage to it, which I didn't really want to do. The next 2 bits down here make up the ratchet section, the top piece there and the little pull there that engages with the internal teeth on the star wheel here, and obviously this goes through and provides the drive to the socket. This star wheel is quite interesting because this is what's giving you the actual torque indication, and the way it's been designed, it actually prevents you from over torquing the setting as well, really. Unlike a normal slip torque wrench, where once you've gone past the setting you can continue to apply turning force and more torque onto the bolt that you're doing up. Just before we get into the rest of it, these 2 bits here, it's just a circlip and a washer that holds the rest of this into the bottom of the body, and then this cap here is glued in. Provide just some insulation around that bottom part and for the sockets to actually engage into to complete the insulation. Now the actual torque mechanism here, you can see this little roller, this will engage with the star wheel. That in turn engages with the actual spring here, which provides the torque. Torque adjustment is from this unit here. That unit is pinned in place with this socket here and these 2 pins, one either side, 180 degrees out, and you can see that they go into these holes in the body and hold that in place. And then as you turn this, you can see as it goes up and you increase the setting, that will compress the spring more to the actual setting that you want, that is seen on the actual gauge here, and that screws onto the body on that, which I have upside down. So turn him around, that actually screws into the body on there and will be pushed up and down as you compress or decompress the spring. You see that through the window here on the body of the torque wrench, so you get the setting there, and then obviously at this end that's compressing up against the drive rod here, and then as you turn this ratchet around, star wheel will move around as you hit your actual torque setting, as at the top of the star wheel there. That's got the spring fully compressed for the particular setting, and then it jumps around and disengages, and again if you try to take this around, it'll just go back to the same torque setting no matter how much you keep turning this around. So as I said, you can't over torque this one. Now in terms of actual adjustment, it looks like if we bring our little gauge up here, for want of a better word, you can see this is actually slotted with a screw going through it. So when you attach this onto the actual body of the setting bar, which we'll try and do, so if that sits in there like that, you can actually do the major adjustment of the setting by changing the position of this as to where you're providing the right level of compression onto the spring. So this is the unit partially assembled, so you can have a bit more of an idea of what's going on. I've assembled the whole of the torque mechanism inside the body there, and then attached a little gauge here to the sliding part that you saw when it was stripped down. This is the outer body that gets slid over the top of this, and then you can see here there's the actual setting value and the little window there, and there's the screw there that you can adjust with a little Phillips Zero, loosen it, and then you can move this gauge up and down to do some calibration and set it where you want it. And you can move it that way or that way. This little lowering pick helps to do that. You can see it moving in the window there. The only thing that I have found as I've tried to adjust this, you can only set this to around about 10 Newton meters. Otherwise, when you go beyond that, this screw disappears up inside the body and you can't access it. So that is a bit of a downfall, and I think I'll wait until the smaller unit turns up to see how well that reads at the 10 Newton meter setting before I can try and set these wrenches a little bit better. But really this one here is obviously defunct with the insulation compromised. It might well still work as an actual torque wrench, but the insulation isn't valid anymore, so it can't be used in that respect. Not much involved in taking these units to bits and putting them back together again. You obviously need the little ratchet there, Allen key, to remove this end screw here that holds the actual cap in place, and you then have this castellated nut that holds this in place that you can just flip around with a screwdriver. And there's the body off. I've already said Phillips there will take this in and out. These, if you compress this whole unit in a vise, these will tap out nice and gently or come out with a magnet, and then that releases the whole of the sliding mechanism for setting the torque, and then that just leaves you with the spring inside. And to get the spring out, you just have to, I think you can see it from here, so you see the spring up against the sliding mechanism there. This spring actually sits up against this little roll pin here, and you can just tap that out. Once this is out of the way, you can tap that out with a hammer, and the little pin punch just there, and then this all slides out, and your head here obviously just circuit pliers to take out the outer circlip. Again, a little O-ring pick gets this inner clip out, and then the head just falls out, and along with the star wheel that then comes out. So yeah, not much to them at all really. That'll be it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next one.